We're going to learn all the possible log rules every student should know in order to solve any log question. Well, not just any, almost 80 to 90% of the questions available. So let's just dive directly into this and see what happens. First being the definition of a log, which is just simply saying that if you have like something like log b, c, or in fact a equals c, then this is the exact same thing as if I say the b to the power c would be equal to a, which is simply one is the exponential form, the other is the logarithmic form. I won't waste more of your time in the definition, but this is logarithmic form. Well, the second thing being the definition itself. The first of them being the product rule. According to the product rule, if you have a log, let's just say b, and then two separate expressions m and n, then if they're being multiplied, you can separate them by a plus sign. You say log b m plus log b n, and as simple as that. We're gonna see all the rules that we learn in action after I'm done with listing all the possible rules, so we could just like refer back. The next rule being the quotient rule. According to the quotient rule, it's kind of similar to product, but obviously since it's a quotient, it's going to involve something regarding division instead of multiplication. So this rule says if you have log b, an expression divided by an expression, you could just simply separate them by saying log b, first expression, the numerator minus the denominator, log b n. It's the same as product except for the difference of a minus because it's being divided. The other rule is power rule, and according to this power rule, it is that if you have log b m and this m has some kind of exponent on it, like let's just say k, then the k would come down and it's going to be k log b m. Again, we're going to see all of these laws in action. And going further, we need to remember a few things which are not law, but like some actual rules that log follows. One being that log, sorry, not log, it's log, base of anything, like this is a b. And if it has the actual argument 1, then it's the same as 0. Now, regardless of whatever b is. Similarly, if log, base, and the argument are the same, like b and b, then it's gonna be 1. So this could be log Musa, it's still gonna give you 1. Log 1, 1 is gonna give you, log 1, 1 is an arbitrary, it's an argument, which we'll not focus right now. The other one being log 2, 2, or be it anything, it's just the argument and the base should be same. The other thing that we all should remember is one of the niches rule, because they don't test it broadly, but it is being tested a lot, is change of base rule. Now, according to this rule, we said that if you have log ba, then you can separate the argument and the base by saying log a over log b. And that being said, another thing to remember, if like let's just say you have anything like log bm, now this m should be always positive because log, basically there's no such thing as negative log. And just to be clear, log bm minus, this is allowed because this minus is not with m, or because even if you just like backtrack, it's gonna be log b m to the power minus 1, which is b log b 1 over m. Still, m is not negative, so we need to make sure that the argument never gets negative. Another thing would be, I think that's it. Those are all the basic log things you should remember, including the definition. Now, the idea for this class was to just like, you can find these definitions online too. The idea for this class was just to like look over problems and how long complicated problems could just be solved by these simple rules. So without wasting further time, let's start with the questions. First being said, it could say like something like this, like you have a question saying log 248 minus log 2 3 plus log 2 and 2. Now, if you clearly see there are minuses and pluses, and we have all learned what these minus and pluses are and mean. So there are no brackets, there's no bed mass or ped mass or whatever you call that right now. So you just simply see the plus sign and you just multiply. So you say log 2, 48 plus 2, which is, sorry, 48 times 2, which is, wait me a sec. So it's gonna be log 48 times 2. What is 48 times 2? 2 is the 16, 2 4 is the 8, 9, 96. Let's just be log 96 minus log 2, 3. And then you just divide 96 by 3 because it's gonna be, again, we're using this quotient rule because there's the minus sign between, we're just going back. So it's gonna be log 296 divided by 3, which will give you log 2, because 96 divided by 3 is 32. So log 232. Now, you may think the question is over, but remember, we can still apply one rule. Why? Because we can just simplify 32 into the power of 2. By how? Because log 2, no, 32 can be written as 2 to the power of 5. Now, if we all remember, we know the power rule, so we will apply power rule, and it's going to be 5 log 2 and 2. And we also know that the base and the argument are same, it's going to be 1. So it's going to be 5 multiplied by 1, and your final answer is 5. The other kind of question you can get is, you can be given a whole expression like log 3, something like 9x squared root y and z cubed. And they may say like expand this. Then don't panic, because this is a scary looking expression, but the thing they're asking is super easy. So you just simply say that log, first you notice the division sign, so you just write log 3, the top part 9x squared root y, and then minus, because of the quotient rule, log z cubed. Now all of these things are being multiplied, so you could just like keep putting consecutive pluses. It's gonna be log 3 9 plus log 3x squared plus log log 3 root y and minus log z cubed. Simple. Now you can just start applying whatever apply. You can apply this log 3. 9 can be written as 3 cubed, and it's gonna be plus log. Now this x square has a square on top, so according to the power rule, we can bring this 2 down. So it's gonna be log 3x plus, it's similarly y has an exponent of 1 over 2, which is indeed the root. So you can just write 1 over 2 log 3y. And over here you can just simply directly bring this 3 down, minus 3 log 2. And I think this is my fault, or no, it's a 2 cubed, so my bad. So you just write 2 cubed like bringing it down. Oh wait a minute, did I make any mistake? Log, yeah, I forgot the 3 here, so it's gonna be log 3 2 square, something like this. Now further, last thing you can do is just simply put this 3 down, and log 3 will be 1 plus 2 log 3x plus half log 3y minus 3 log 3 2, and that's it. You cannot do anything else. So this is your most expanded form you can imagine. And what else can we do? Oh, by the way, I made a small error, because 3 cubed is not 9, it's 27, so it's gonna be 3 square, and in the end it's gonna be 2 here. And yeah, that's it. Another thing they can just simply ask you is like some sort of thing, like maybe this, like log 5 25x plus log 5 to the power 2 minus x, and then they just simply say simplify this. Then what are you gonna do? First you apply you just simplify the things you can. So first, like log 5, and you can write 25 as 5 square, so you write 5 to the power of 2x plus, similarly over here you just notice you cannot do pretty much anything, so you just like leave it like that maybe for now, log 5 2 minus x. And now if you remember, we both have plus so we pull these two x's, I mean the exponents down, so it's gonna be 2x log 5 and on here it's gonna be 2 minus x log 5 Now this log 5 becomes 1, and you're left with 2x times 1 plus 2 minus x. If you further simplify, the 2x minus x will give you x, and then you're left with x plus 2. Pretty simple. Similarly, you can have some sort of like quadratics involved in there too, by saying question something like log 2x minus 1 plus log 2 x minus 3 equals 3. And this could be solved something by saying there's a plus sign, so you multiply them. Log 2 x minus 1 multiplied by x minus 3 equals 3. And then you can just simply say apply the change of base, apply the definition, in fact, which being said that remember this definition, like log AB equals C is the same as B AC equals B. We're going to apply the same definition here. We're going to say this x minus 1 multiplied by x minus 3 is the same as the base with the exponent of the answer, something like this. Then you write it further, you write x minus 1, x minus 3, and this turned out to be 8. Then you try to solve it further, you expand this, you get x squared minus x minus, you get x squared minus 3x, and then you get minus x, and then you get minus plus 4 equals 8. And then you get minus 1 plus times 3, it's just simply 3. And then you notice you get x squared minus 3x minus 3x minus x will give you minus 4x plus 3 equals 8. You bring the 8 on the other side, and you're left with x squared minus 4x minus 5 equals 0. Now it's a quadratic equation. You can apply middle term breaking or whatever you want, and then you'll have your answer. So you need to find two numbers that when you multiply they give you minus 5, but when you add them they give you minus 4. So you can just simply think of minus 4 multiplied by or in fact no minus 4, you can just simply think as minus 5 multiplied by 1. And now if you do minus 5 plus 1, it will give you minus 4. So there you have it, your two numbers. You write x squared minus 5x minus 1x minus 5 equals 0, and then you just take out the x common, you're left with x minus 5, minus 1 common, you're left with x minus 5, and what else, minus 5, I put a minus here, it should be plus. And then if I do this, if I pull up minus, I think I made some sort of an error. X minus 4x minus 5. So I think I get this correct. I did this correct. See, I also make mistakes. You're not the only one out there making mistakes. And then you just pull out x here. It's gonna be x minus 5. You pull out plus 1. That was the error. And then you're left with x minus 5. Now it's equal to 0. You take out the first bracket, x minus 5. The other one being the leftovers, x plus 1 equals 0. Now, a lot of students think they have cracked it. They just simply say x is equals to 5 and x is equals to minus 1. Now, if you just leave it like that, you'll still get a 0. Why? Because, remember, this x eventually fits in this argument of the log, remember? And what did I taught you about the argument of the log? I said the argument should always be positive. So with that justification, we say that the x should be not negative. Because if I put minus 1 here, look what happens. If I put minus 1 here, what happens? Log 2 minus 1 minus 3, this will give you 4. So it's going to be log 2 minus 4. And this is not allowed. So that's why we cannot put minus 1 in. So you say that you reject minus 1 because of negative logs. And you say x equals 5 is your answer. And you reject this. And yeah, that's how you involve quadratics with this, and you can low-key do any question you want. Another thing being like ln x squared equals 4. Now this is pretty easy because it's just simply asking to just like simplify. So you just apply the definition. You say ln, whenever nothing is mentioned with ln, there's always a small e here. So you say e to the power 4 is x squared. Now you just simply find the value of x. You just square root both sides. So you say 1 over 2, 1 over 2, and whenever you root both sides, you do plus minus 1, and then you are left with x being plus minus e squared. And yeah, that's it. Pretty much, that's it for today's class. And these were like one of the longest questions I figured out on the internet. And do give them a try, and if you find any problems, just send it to me on my mail. And until the next video, have a good day.